So, in the earlier lecture we have seen how a function can be invoked and it returns the values. As we had mentioned that it is not the case that always a function will return a value. Here is an example. You look at this function div7, which says, that means the purpose of this function is to find out whether a particular number that is passed on to it as a parameter whether that is divisible by 7 or not. So, the code is very simple. What should you do? If n is divisible by 7, that means if n modulus 7 is equal to 0, then we say printf n is divisible by 7. Otherwise, we print n is not divisible by 7. Now, in this case we are just printing from here, straight the printing is coming out from here. The main function is only passing on the value, reading some value of n and passing on that value of n here, or maybe here it is n is the argument. So, might be the main program is reading a value num and passing that value num here. Now, this num is also of type integer and the rest of the things are being done by the function. It is testing whether it is divisible by 7. If it is divisible by 7, it is printing like that, otherwise it is printing the other message. Now, in this case putting this return is optional, because even if I did not put the return, when I would have met this parenthesis, this end bracket, it would automatically return to the calling point. However, there is no harm if I put the return. Okay. So, returning control, we have seen that how the thing is invoked by parameter passing. Now, returning control, if nothing is returned, then we can simply write return semicolon, or we can skip that and until it comes to the right brace, that is last right brace, that is automatically taken as the return. But if something is to be returned, then we must put the return statement with, say, maybe return a times b, some expression, or it could be return c, or it could be something like return 0 or return 1, whatever. We have to do something, some expression, and expression automatically will also capture the constants. So, now let us look at this example. Here you see the layout is also important. Here we are first writing the function, this is the function. The function declaration is coming first, square of x, square of an integer x, and square of an integer x will also be an integer. Therefore, the type of the function is int, as you can see here. So, that is, this whole thing is the function declaration. Then starts the body of the function. So, here the function declaration consists of the name of the function and the parameter, that is x of type integer, and this int here is the return data type, the type of the data type that will be returned. So, these three together make the function declaration. Next, we are coming to the body of the function. Int y, what is that? That is a temporary variable. 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 That is a tem temporary variable. Why I am calling it temporary? Because it leaves as long as this function is active. As soon as the function ends, the role, the definition of this y is also lost. Okay. So, here you see, we will come to that later, but here you see that this is an internal variable. Here I am computing the square y assigned x times x, and I am returning y. I am returning y, and after return that y vanishes. Okay. Why? Where is y returning to? Wherever the square has been called. Now, here you see, here is a sum of square. What is main doing? Now, let us come to main. Main has got some variables a, b, and sum of square is another variable. So, printf give a and b, I am reading a and b. Now, I am calling this function twice, first with a parameter a, next with a parameter b, and a and b are, in sequence goes to this argument x, and the square of a is computed. So, return y will return first here a square. So, we get a square here, then this is called, and y is returned here. So, we get b square, and then these two are added and we get sum of square. All right. And then we are printing the sum of square. So, you can also try to see what is the flow of data in such cases. All right. Let us move ahead. So, these are the parameters passed, and here is the argument, you can see that. Now, invoking a function call, here the same thing. What is happening when the thing that I just now explained, when I am saying, now let us see what happens to the variables. Assume that the value of a that has been read here is 10, all right. Then square of a means square of 10. So, 10 goes to x, right. So, a is 10 here, that goes to x. So, x becomes 10. Now, we compute y, which is 10 times 10, I am getting y is becoming 100, right. Now, this 100 is coming here. Actually, this arrow is a little wrong here. So, it will be actually coming to this point. Okay. Clear? Next, suppose, so in that case, so similarly, it will be for b, if b was some value, that is the how, then x, suppose b was 7, then x will get 7, and then y will be 49, and 49 will come to that square of b. So, 100 plus 49 will now be added and will be kept as the sum of square. So, in the earlier example, you could see that in the earlier example, the function was written and then the main. Now, let us go ahead. Function definition. So, we have seen that a function name preceded by a return value type and declaration statement, and then the function body. I am repeating certain things. Variables can be declared inside the blocks. The blocks can be nested, that means there can be multiple blocks. Function cannot be defined inside another function. This must be clearly understood. A function cannot be defined within another function. and returning of control. The control will have to be returned as we have seen. If nothing returned, then return, we have already seen that. If something is returned, then return that expression. Here again another example of function. The more examples you do, the better you will understand. Here the function, as the name implies, you see it is always better to use meaningful names for functions. Sum of digits of n. So, if there be a number like 125, then I am trying to extract this digits 1 plus 2 plus 5. So, that will be 8. That is what my program wants to do. So, initially sum is equal to 0, while n is not equal to 0, sum is sum plus remainder. So, 125, if I divide by 10, then I will have 12 here and remainder is 5. So, sum plus 5, so sum becomes 5, clear. Now, then we find out the dividend, that is 12, and again divide that by 10, we get 2 to be the remainder. So, we take sum to be 5 plus 2 and so on and so forth. Ultimately, I am getting the sum. So, return sum. This is another example of a function. Here you can see that this n is coming as a parameter. All this sum is an internal variable and will not have life beyond the body of the program. So, here you see sum of digits is a function name, int is a return data type, parameter list is that, local variable is sum. Sum is a local variable and return statement is return sum, clear. All these we have already discussed. This is merely a division, and here you can see that the return can have an expression. Here only a variable is an expression. Now, we come to a very important concept which I was mentioning in the passing, that the life of an variable internal to a function exists as long as the function is live, as long as the function is active. Now, that formally is called the scope of the variable or the variable scope. So, let us look here, there is an interesting program. Now, here you see my entry point is the main, but even before that I have declared a variable int a. That means, this a is a global variable. That means, it is there always. Suppose it is a value 100, then it remains, this is retained. So, let us keep this and let us see what happens. Now, I am entering main and I have assigned a to 1. Okay. Now, that means, now inside this function, inside this main, I have got mains a, which is another a. Let me write it in, is it visible? Let me do it in a better way. So, there is one a, I am calling that a g, that is this a is a g, that is the global a, and suppose that is 100. Now, this is another a which is defined in the main. So, the function, this will be live inside main. So, let me call it a m, all right. So, now a becomes 1 here, as I come here a 1, then I am calling myproc a function, myproc. From here it comes to myproc, and suppose myproc has got another a here. So, let me call that to be a x, just for understanding that it is of myproc, or let me call it of the function, right. So, a f. Now, that is initialized to 2. Now, you see how many different a's I have, multiple a's. Now, inside this block I initialize another a to be 3. So, that is another a, that means this one is not being disturbed. A is 2, and while a is 2, I am making another a, because here I am declaring, you see, this is a pure declaration, int a. If I had just written a, assigned 3, then this a would be assigned 3. But here I have declared another a, int a. Therefore, there is another a coming within this while block, that I am calling a b, and that is becoming 3. Now, I am printing a. Which a will be printed? The innermost, the current a, that means 3 will be printed. Then I break. Break means what? I come out of the while loop. We have learned break. So, we come out of the while loop, and then I print a. Which a is? So, as soon as I break out of this, this is gone, no longer live. So, I am coming here. Now, which a is in my scope? Which a is in my scope? My scope is this, I am within this function. So, this a, so that will be printed here. So, 2. Oh, there was some backslash n, I am ignoring them, that will come one after another. And then I come out of this, it is over. So, I go to this main function, go back, sorry, not here, I am sorry, it should go back to this point. That means, I will now execute print. Which a is in my scope now? I have come out of this, function, so its scope is also gone. So, the scope of this function main is now live. So, what is the value? 1. So, that will be printed. Okay. That is how the things will be printed. So, we will repeat it if necessary, but let us try to see the execution now. So, if I first do it, then this one will be printed, a assigned 3. Next, that is gone. So, here a will be, this will be assigned, a assigned 2. Then I will go up there, and the a that is in the scope of this function, that will be assigned, and then, so that will be assigned. Okay. You see, although I declared a global a, internally when I declare some other a, this global a, look here, a point has to be seen. I declared a global a here, a global a was here, a g, that was declared. Here I have assigned to a, I have not declared another a, I have not written int a, I have simply written a assigned 1. That means, the a that was there is already existing globally, that has been assigned 1. But when I come here and I am declaring int a internally inside this process, another a is created, which is the a of the function, and that is assigned by to 2, not this one. There are 2 distinct entities. Now, again here I have declared another a. So, since I have declared another a, this is the a of this while loop might be, and that is becoming 3, and accordingly the corresponding, whenever I say print, which one will be printed, will be the one that is within its scope. This A is in the scope of this. So, that was printed. This and gone, this A was in the scope of this. So, printed and gone, and this A is in the scope of this, and this is printed. So, this is known as the scope of variables. Okay. So, if we summarize functions, you can see this, I do not know how much is visible. So, main function, I am calling a function factorial, and we have already seen that, and then the function is having different, it is a self-contained program which has got its named function definition, where the type of the argument is also specified. Now, main is a function, and here I am calling a function, I am actually calling a function by name, calling by name, and is a return data type, repeating that the function name is there, the parameter is there, and the return statement. Okay. And the other variables like temp and all those are local variables we have repeated. Now, some point is a function cannot be defined within another function, which we have told, but I am repeating it again. All function definitions must be disjoint. That means, I cannot define one function within another. Nested function calls are allowed. What is meant by nested function call? Nested function call means, that suppose here is a main program going on. I call a function, this is function say f1, and this was my main. From some point in the function, in order to solve this problem f1, I may call another function f2, this is nesting, calling, but not defined. They are defined separately, f1 defined separately, f2 defined separately, m defined separately. Now, from f2 I may call another function f3, and f3 completes. f2 has called f3 because of some reason. So, that reason is answered, I mean for some value or for some computation, that computation has been done. From here it returns to the point from where it was called. So, this is the return point. So, is it clear, or should I use some other color for the return point? Is it necessary? So, I am not getting the color. So, let me use the existing color whatever was there. So, where did it go? So, from here now the color has come. So, I can show the return here, I am returning, but then again I am continuing with this function, and when f2 is over, then I again return to f1. So, it was called f1 called f2 for some purpose, that purpose is solved. So, I return here, and then f1 continues again in its whatever it was doing, and f1 was called by main for some particular reason. When that purpose is served, then we return to this point, and then main continues, right, and ultimately main ends with this bracket. Now, here this is known as nesting. That means, nesting of calls. So, I have made a call, and from that call I can make another call, from there I can make another call. But the point to note is that all these functions must be independently and separately defined. They cannot be defined one among the other. Okay. So, nested function calls are allowed. A calls B, B calls C, as I have shown, M calls F1, F1 calls F2, F2 calls F3, like that it can happen. The function called last will be the first to return. Obviously, we have seen that in our earlier slide, that we go back to the F4, from F4 I return to F2 and like that. And so, a function can also call itself either directly or in a cycle. We will see this separately, what is meant by that. A calls B, this can be in two ways. One is that, say, A calls B, B calls C, C calls back A, that is possible. Like, say, here if we see that main was running, it called F1, F1 called F2, and then F2 can again call F1, and then this call, ultimately for this call the return has to come here, and ultimately it will have to return here, etc. So, this part we will have to see separately. That is, it is a function, one function is calling another, and that can be in a cycle, F1 calling F2, F2 calling F1, it can happen. Or recursion means, say, a particular function F1 calling itself, F1 is calling itself a number of times. That requires a special attention and a special discussion that we have to carry out. We will do that in subsequently, but right now just let us remember that this calls can be in a cycle or it can be called to itself, which is a recursion. Now, we have got some math library functions which perform common mathematical calculations, and I do not remember whether in an earlier class I mistakenly said that I had mistakenly, I do not remember exactly whether I did that or not, that you need to include, just as we include math.stdio.h, similarly we have to include math.h. Okay. So, just as we include stdio.h, if we use some mathematical functions which are already available in the C library, we have to include math.h. I do not remember whether while first introducing the square root function, I might be mistakenly I wrote math.lib, that is a library function. So, .lib if I had said that, you should ignore, it is math.h, okay. Include math.h, and so here there is an important thing. When I compile, any function that we any program that we write, we have to compile it in order to get an executable code. Now, in your exercises you must have done by now that typically you compile a C program like this, cc myproc.c, right. But if you use some mathematical library in your function, then you should write cc minus lm myproc.c, or that means link to the mathematical library. You compile, first you compile. Now, you see what is happening is the mathematical libraries are here, say some square root function. Somebody has written for you and that is in the C library, all right. Maybe some other function like 2 upper, which converts from lower case to upper case, all these things are there. Now, 2 upper is a separate library, but square root is a math library. So, if in your function if in your program you refer to the square root, some mathematical library, then you must do this. Why? Because purely myproc.c will generate some object code, all right, object code. Now, the code for this has to be linked to this, has to be linked, so that your ultimately the full executable code also takes this into account. This code linked to this code will be forming your executable code, because the square root you will need anyway at the time of running it, right. So, here it is shown minus lm at the later also, CC program name and then link with the mathematical library. Format for calling the functions, forget about this, let us make it for the time being ignore this, just say %f function name. So, this is point number 1. There are many mathematical library functions. In order to use them, we have to include immediately after stdio.h hash include math.h, and we must use this, give this linking command. Now, when we call the function name argument, if multiple arguments, then we can use a comma separated list. Okay. Say for example, printf some format the square root 9, there is only one argument, not much. Arguments may be constant, variables or expressions. Okay. All math, now this is important, all math functions return the data type double. This is important, you should keep in mind this for C, all the math functions are returning the data type double. So, in order to make it compatible with the variable where you accept the value returned by the math function, that should also be double. Okay. Arguments may be constants or variables. So, here are some examples of math library function, like finding the cos of some angle x, finding the sine, that is all these functions are known as a sine, a cos, a tan, inverse tan, arctan, okay, ceiling function, floor function. Floor function means it finds the greatest largest integral value that is less than x. Suppose some is 200.56. So, the largest integral value is 200, that is the floor function. So, cos, a cos is finding the cos of an angle in degree, whereas a cos cos is for finding the cosine of an angle in radian. Now, there is no point in memorizing them, as and when you need them, look at the manual, look at the book, and very soon you will get accustomed to the different library which are available for C. And we will come back to this in the next lecture about some more very well known functions which you have already encountered with, and then we will proceed further with recursion. Thank you.